In this session, we shall look at the topic differential equations. First of all, what is meant by a differential equation? Let us try to understand. Consider the function y is equal to mx plus c. Differentiate it with on both the sides. Dy by dx is equal to m. Dy by dx is equal to m. So d square y by dx square is equal to 0. Isn't it? In this equation, dy by dx, that is the differential coefficient, is involved. Isn't it? Observe one more equation. X dy by dx plus y square into d square y by dx square whole cube is equal to 0. That is another equation in which the independent variable x and dependent variable y and differential coefficients, namely dy by dx and second order derivative d square y by dx square, is also involved. All such equations in which x, y, dy by dx, that is y dash, or dy by dx, d square y by dx square, etc., 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 is a differential equation. That equation in which differentials or differential coefficients are involved is nothing but called a differential equation, in which x, y may be present or may not be present. We are just not bothering about that. Such an equation is termed as a differential equation. Okay, under this heading differential equation, we study the nature of differential equations at different states. In the first stage, we know what is meant by order of a differential equation, what is meant by degree of a differential equation. We entirely focus our attention on this particular heading now. And later on, how to produce differential equations, whose solution is the given equation. Number 3, the next one, how to solve differential equation, to get the solution of the differential equation. This part is bulky. There are so many methods in that. Well, let us concentrate on these 3 branches individually and separately. We shall now focus our attention to know degree of a differential equation and order of a differential equation. What is meant by that? For the sake of knowing those things, namely order of a differential equation and degree of a differential equation, let me create some differential equations. Let me give you a list of some differential equations. The first differential equation is x square plus 1 into dy by dx plus y cube into dy by dx whole square plus 1 is equal to 0. 3 dy by dx plus sin x into d square y by dx square is equal to 0. One more, e power x into dy by dx, e power x into dy by dx plus tan inverse x into dy by dx, 3 tan inverse x into dy by dx minus 1 is equal to 0. Well, in this equation, dy by dx is only present. That is, the first ordered differential coefficient is only present. Here, second ordered derivative is also there. Second ordered differential coefficient is also there. Let me change this equation. Dx cube y by dx cube. Observe this equation. This is the largest ordered differential coefficient is of third order, isn't it? This is the first order derivative only, but this is the third order derivative. What is the largest order of the differential coefficient present there? 3. I think you are following me. you consider three differential equations. The largest ordered derivative present in the third equation is dy by dx only. In the second equation, the largest ordered differential coefficient is of second order, that is d square y by dx square is present. But here you are able to see d cube y by dx cube also. Depending on the different order of the differential coefficient present in the differential equation, we define the order of this order of the equation. This is of first order, this is of second order, this is of third order. This is of third order because the third order differential coefficient, third order derivative, that is d cube y by dx cube, is present there. Should it be present at once only? Not necessary. Not necessary. You look here, dy by dx and dy by dx, two times it is occurring. We do not bother about it. What is the largest order of the differential coefficient? First order derivative is there. So this is of first order, this is of second order, this is of third order. That is about order of a differential equation. So in a nutshell, in brief to say, what can you define the order of a differential equation? A differential equation is said to be of nth order if there will be no differential coefficient of n plus 1th order in that equation, and there is d power n y by dx power n. So the largest ordered differential coefficient present in that differential equation is nothing but the order of the differential equation. According to that sense and sentence, we reveal that this is of first order, this is of second order, and this is of third order. Well friends, we could have recollected the meaning of the order of a differential equation. Now, let us try to know the word degree of a differential equation. How can it be defined, or how can it be understood? Let us see. To understand the degree of a differential equation also, let us observe some more differential equations. They are going to be written on the board. You please observe me carefully. 3 dy by dx plus x plus 1 into dy by dx whole square plus tan x is equal to 0. 5x square plus 4 into d square y by dx square whole cube plus e power x into dy by dx whole to the power of 5 plus sin x is equal to 0. 4 e power x into d cube y by dx cube plus tan x into d square y by dx square whole cube plus x plus 3 into dy by dx plus y to the power of 5 is equal to 0. Y to the power of 5 is equal to 0. Well, my dear, we are to know about degree of the differential equation. First of all, you please tell me order of these three differential equations. What is the order of this differential equation? First order. Why? Because dy by dx is only present. What is the order of this equation? Second order. Why? Because d square y by dx square is also there. This is a first order, this is a first order derivative, and this is a second order derivative, hence the equation of, the order of this differential equation is 2. Similarly, what is said about the order of this differential equation? 3. Why? Because third order derivative is present. Well, my dear, we must be very cautious and particular about the degree of a differential equation. At our earlier classes, to know the degree of a polynomial equation, we were seeing the largest exponent of the variable, if at all it is an equation of one variable. If you fix that concept in your mind, sometimes it might be difficult to trace the degree of the equation. Look here, the largest power exponent is 2 here. The largest exponent is 5 here. The largest exponent is 5 here. That is not the case to decide the degree of the equation. Now you follow the word. The largest exponent present to the largest ordered derivative is the degree of the equation. Is the degree of the equation. Well, my dear, what is the largest ordered derivative here? dy by dx. Its largest exponent is 2. So this equation is of first order and second degree. Look here. Here the largest exponent is 5, but here it is 3. What do you say? What is the degree of this equation? Is it 3 or 5? You are supposed to have or supposed to note the largest exponent present on the largest ordered derivative. Your eyes must look for the largest ordered derivative only. This is the largest order derivative. So this is of third degree. Second order, third degree. What do you say about this? Whole power 3 is there. Whole power 5 is there. You do not look at that. You have to look at the largest order derivative only. What is the largest order derivative here? d cube by dx cube is there. So it is a third order derivative. Its exponent is, there is no 1. It is 1. So what is saying? This is of third order, first degree. This is second order, third degree. This is first order, second degree. Now you tell me the answer for this one. X plus 1 into dy by dx plus 5 minus tan inverse x is equal to 0. What is the degree and order of this equation? Come on. dy by dx is only present here. So this is a first order. This is a first order. And no more exponent is there. Of course, it is believed it is 1. What is the exponent given to the largest order derivative here? It is 1. So first order and first degree. Therefore, from this discussion, you can easily understand that those equations of first order and first degree will contain just dy by dx only. No question of having dy by dx whole square, dy by dx whole cube, something like that. Such things will not happen. You will have dy by dx only. So, in this way, we proceed to find the order and degree of a differential equation. You see, one more angle of observation is also here to decide the degree of the equation. At times, in some equations, some radical powers might also be occurring. In such a case, you are supposed to remove them by squaring or cubing or raising to a necessary power. Then only you decide the degree of the equation. To understand this sentence very carefully, let me give you some more examples. X plus 1 into d square y by dx square plus 3y minus 2e power x into dy by dx whole to the power of 3 by 2 whole power 3 by 2 is equal to 5. In the exponent 3 by 2 is there. So that is with radical exponent. It is to be removed. It is to be removed. It is to be removed. Therefore, for that we generally square it on both sides or cube it on both sides. We square it on both sides so that it happens d square y by dx square whole square might be observing here. After simplifying, that is raising to the power 2, you will be going to look at d square y by dx square whole square. Come on, tell me, what is the order and degree of this equation? This is of second order and second degree. Why? Because the largest ordered derivative is expressed with the exponent 2. The largest exponent, of course. So, the answer is, it is of second order and second degree. Suppose this exponent is 3 to the power of 5, sorry, whole to the power of 3 by 5. What happens to this? To eliminate that, you will rise to the power of 5, isn't it? You will rise to the power 5. Then you will be observing d square y by dx square whole to the power of 5 in the resultant equation after getting all the simplifications. What can you say about the degree of the differential equation at that instant? It is 5, of course. So, well, my dear friends, you please be careful in taking the decision about degree of a differential equation. You first of all look for the largest order derivative present in that, and then you check the entire equation. Is there any radical power? Is there any radical power? You try to remove that radical power by rising suitably to certain power. Then only take the decision about the degree of the differential equation. Like that, you take the order and degree of a differential equation. And in brief, let us try to give a statement regarding order and degree of a differential equation. First of all, order. What do you mean by order of a differential equation? The order of the largest ordered derivative present in the equation, that is differential equation, is called order of the differential equation. And then degree. Degree of the differential equation is the largest exponent with which the largest ordered derivative is expressed in the equation is called the degree of the equation, provided the radical powers, if any, are eliminated. That is the degree of this equation. Well, friends, we could have completed the first stanza of this chapter, differential equations, that is order and degree. We could have known well. Well, the next one is producing a differential equation, or preparing a differential equation, or constructing a differential equation, like that. Yes, look here. Suppose y is equal to mx. Y is equal to mx. You differentiate it on both the sides. Y dash or y1 is equal to m. You substitute y1 for m here. Y is equal to xy1. This equation is free from arbitrary constants. This is an equation, differential equation. This has been obtained from this one. That is why we say that this is the differential equation whose solution is this. This is the differential equation whose solution is this. One more thing, suppose y is equal to a into e power x plus b into e power minus x. Differentiate with respect to x on both sides. A e power x minus b e power minus x. Again, the constants a and b are appearing. That's not the answer. This is not the differential equation of this one. Again, differentiate it. y2 is equal to a into e power x plus b into e power minus x. So we have got y2 is equal to y. Stop there. Stop there. No more arbitrary constants are present here. This is the differential equation whose solution is this equation. Another typical discussion is existing here. Now I again differentiate it. What happens? y3 is equal to y1. Anything wrong? No doubt this is a differential equation. Nobody can say no. You see, this is a differential equation. I do agree with that. But this is not the differential equation whose solution is this. Why? Because the number of constants here is 2. Order of this equation is also 2. That must be the rule which is to be satisfied. If an ordinary equation is given and you are supposed to prepare or you are supposed to construct a differential equation whose solution is this equation, you count the number of arbitrary constants which are to be eliminated in the given equation. The number of such constants must be equal to the order of that equation, order of that differential equation. It should not exceed that. Here, what is the sin you have committed? There are only 2 constants, but you have differentiated thrice. It is not the differential equation whose solution is this. Why? What is the reason? Why should we follow that rule or regulation? You see, this is y3 is equal to y. In order to get the solution, you have to move back. Moving back means you have to integrate thrice here. You have to integrate with respect to x 3 times. Each time you will be having a constant of integration. In that fashion, if you integrate with respect to x 3 times, you will be supposed to have 3 arbitrary constants, which is not true. There are just 2 only. That is why if an ordinary equation is given and if you are supposed to prepare a differential equation whose solution is the given equation, you can differentiate with respect to x at most n times, where n is the number of arbitrary constants present in that. Not less than n, not more than n. If it is less than n, arbitrary constants will remain. You look here, in this equation, we have just differentiated once. No question of elimination of the constants. Again, they are appearing. So, differential equation must be free from arbitrary constants. In the very beginning, in the very definition itself, we could have known capital F of x, y, y dash, y double dash, y triple dash, and so on. That must be the nature of the differential equation, isn't it? So, you please keep in mind that the number of arbitrary constants in the ordinary equation is exactly equal to order of the differential equation whose solution is the given equation. Yes, that must be followed. Okay, friend. Now, we shall look at preparing the differential equations for different curves. Y is equal to mx plus c. The question will be, what is the differential equation of the given equation y is equal to mx plus c, eliminating the constant c and m? He gives, of course. In some problem, he may not give you. Suppose, what is the differential equation of family of all circles centered at origin? Suppose, question is there. We know that x square plus y square is equal to r square is there. R is the parameter there. That is the arbitrary constant or parameter. You eliminate that. In most of the cases, he gives the constants which are to be eliminated. Then there are 2 constants to be eliminated. In the starting itself, in the beginning itself, you must have a particular fixed idea. What is that idea? How many number of times should we differentiate? 2 means 2 times only. Not less than 2, not more than 2. Come on. Y1 is equal to m. M is there. Y2 is equal to 0. Stop there. No constants. This is the differential equation whose solution is this. If only c is to be eliminated, then this is the differential equation. Isn't it? Like that we produce. Okay, let us know the standard structures in coordinate geometry Let us start from the straight lines. What is the differential equation of the family of all straight lines passing through origin? Very first question. Family of all straight lines passing through origin. You must be able to recollect the original equation. Y is equal to mx. What is the parameter there? M. If you change m, another line of the same family will be obtained passing through the origin. So m is the parameter. What is the differential equation for this straight line? Y1 is equal to m. Therefore, y is equal to xy1. No constant is given in brackets to be eliminated. We have to understand there m is to be eliminated. So what is the equation? Y is equal to xy1 is the differential equation. Y is equal to xy1 is the differential equation. And then number 2. Equation of the straight lines passing through origin we have known. General equation of a straight line ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. That is the given equation. What is the general differential equation of this family? You do one thing. You can convert this into y is equal to mx plus c. You can convert this into y is equal to mx plus c, provided a is not 0. Y is equal to mx plus c. You can easily convert. Now we could have reduced the number of arbitrary constants which are to be eliminated. Now what is the differential equation? Just now previously we have seen what is that? Y2 is equal to 0. D square y by dx square is equal to 0 is the differential equation. Okay, next one. What is the differential equation of the family of parabolas? Vertex with vertex at origin and whose axis is x-axis. That is the next thing. We could have seen straight lines. Now let us concentrate on different parabolas. Y square is equal to 4x. What is the parameter there? A. So the examiner means that a is to be eliminated here. Come on friend. 2y1 is equal to 4a. Therefore y square is equal to, in the place of 4a you can write 2y1. And you can cancel y also. Y is equal to 2xy1 is the differential equation. You need not remember, my dear friend. It is very simple. On the spot itself we can find them. We can obtain them. Yes. This is the parabola y square is equal to 4x with vertex at origin and with axis as x-axis. What is the differential equation of the family of parabolas whose axis is y-axis and vertex is origin? What is the parabola? X square is equal to 4ay. X square is equal to 4ay. And parameter is of course a. So what is to be eliminated then? What is to be eliminated? A is to be eliminated. Okay, come on. Differentiate with respect to x on both sides. What are you going to have? Come on. 2x is equal to 4a into dy by dx. That is y1. Well, therefore 2x by y1. 2x by y1. Now we replace this in the given equation so that it becomes x square is equal to 2x by y1 into y. We can cancel x on both sides so that you have x y1 is equal to 2y is the differential equation. Okay. Can you differentiate again with respect to x on both sides? You are not supposed to. You are not supposed to do that. Why? Just there is only one constant to be eliminated. If at all you do that, then it becomes second order differential equation. It should not be true. The order of the differential equation must be equal to the number of arbitrary constants, rather number of parameters, a number of arbitrary constants to be eliminated. So it must be one only. So that is the equation, differential equation of that family. What is the differential equation of the family of parabolas 4a into x plus a? 4a into x plus a. Here, of course, the vertex is not at origin. It is minus here 0, isn't it? It is minus here 0 is the vertex. Okay. What is the differential equation? Well, my dear, how many constants are to be eliminated here? Only one. What is that? What is that? A. Okay. This is equal to 4ax plus 4a square. Correct? Correct. Hence, y square is equal to this. Well, friend, you please tell me how many times you can differentiate on both sides. Just only once. Why? There is only one constant here to be eliminated. Hence, the number of times you can differentiate is only one. Okay, let us do that. Differentiating with respect to x on both sides. What is the derivative of y square? 2y y1 is equal to 4a. That's all. Isn't it? It is 4a. And from h you can have a is equal to y1 by 2. Am I correct? On 12 we cancel, 2a is equal to y by 1 and hence a is equal to y by 1 by 2. Why is it necessary to know a? We will be going to substitute this there. Come on, what is going to happen? Y square is equal to 4 into y by 1 by 2 into x plus y by 1 by 2. Okay, this is equal to, you can cancel one y, no problem. 4 by 2 is 2. 2y1 into x, 2xy1. 2 into 2 will be cancelled plus y1 square. Y is equal. Isn't it? This is 2. 2 into xy1, 2xy1. 2 into 2 gets cancelled. y1 into y1, y1 square. At last, y1 square plus 2xy1 minus y is equal to 0 is the required differential equation. You notice the order and degree of the differential equation. What is the order of this differential equation? It is of first order. It is of first order because just y1 is there. No question of y2, y3 or any other things are not present here. So it is of first order. And what is say about the degree of the equation? y1 square is visible. It is of second degree. First order and second degree equation. It is, this is about y square is equal to 4a into x plus a. Well then, next one. So far we have seen the differential equations of different parabolas. Let us turn our head towards ellipse. Ellipse. What is the standard equation of an ellipse? X square by a square plus y square by b square is equal to 1. What is the differential equation of the family of ellipses centered at origin and axis as the major axis and minor axis along the coordinate axis? Such a lengthy sentence will be given. We know that such an equation is just x square by a square plus y square by b square is equal to 1. What are the parameters here? A and b. So what are the things to be eliminated? A and b. What is the number of constants to be eliminated? 2. So you are permitted to differentiate the steps or equations at most 2 times only. Let us start. 2x by a square plus 2y y1 by b square is equal to 0. Okay. So 2 can be cancelled. From this, y1 by b square is equal to minus x by a square. Therefore, y1 by x is equal to minus b square by a square. Now you differentiate this with respect to x, because I could have brought both the two constants at one side. As you see, this minus b square by a square entirely is a constant. While you are differentiating, its derivative vanishes, thereby both a and b eliminated at one instant. Yes, differentiate with respect to x on both sides. u dash v minus v dash u by v square is equal to 0. How can we get the step? By differentiating this with respect to x on both sides. You see, minus b square by a square is a constant, hence its derivative is 0. Even if you cross multiply, x square also goes there. What is the derivative of y1? U derivative into v, y1 into y1 plus v derivative into u, y2 into y into x minus derivative of x is 1, y1 is therefore equal to 0. xy y2 plus xy1 square minus y1 is equal to 0 is the required equation. Well, my dear friend, you please tell me the order and degree of the differential equation. Some square is being observed. Do you mean to say that its degree is 2? No. Why? Because the order of the differential equation is 2 because y2 is present. The largest ordered derivative involved in the equation is y2. So it is of second order. If at all you like to look at the exponents, you look at the exponents for y2 only. There is only 1 here. So it is of second order and first degree. It is of second order and first degree. This is the equation of this ellipse. Yes. Suppose you are given a system of hyperbolas like this. What is the equation of this system of hyperbolas? Just like in the previous case, you will be having just with respect to, instead of plus sign, we have minus sign here. Almost all the steps will be repeated with minor changes. So you can look at the differential equation very easily. Okay then. This is the case of a hyperbola. Well done. Another. What is the differential equation of the rectangular hyperbolas? What is the standard equation of a rectangular hyperbola? X square minus y square is equal to a square. What is the speciality here? There is only one constant, that is a, to be eliminated. How many? Only one. So at most, how many times you can differentiate? You can differentiate it only one time only. So differentiate it. 2x minus 2y1 is equal to 0. Enough. The constant a has been eliminated. We should feel happy. There is only one constant. There is a that is to be eliminated. We have done. We could have eliminated by differentiating with just one time only. Therefore, the answer is x is equal to y1 is the equation. Is the equation. Well, depending on the sentence given in the question, you are supposed to trace the standard equation of the family. After knowing the family only, you will be able to have the differential equation. We will observe that importance in the next problem. The differential equation of family of rectangular hyperbolas whose asymptotes lie along the coordinate axis. That's all the sentence he has given. You follow the sentence carefully. The differential equation of the family of rectangular hyperbolas whose asymptotes lie along the coordinate axis is. There has been a special structure. You might have remembered it. What is that? xy is equal to c square or xy is equal to a square. Like that you can have. So, unless you know the standard form, you cannot get the differential equation. What is the standard form? xy is equal to c square. There is only one constant c that is to be eliminated. Hence, we have to differentiate only once. Differentiate it with respect to x. U derivative into v plus v derivative into u is equal to 0. That's all, nothing more than that. That's all, nothing more than that is the differential equation. So y plus xy1 is equal to 0. Come on friends, what is the order and degree of this differential equation? It is a first order and first degree. It is a first order and first degree. Why? Because it is a first order because y1 is appearing, y1 is involved. That is dy by dx is only involved. Its order is 1. Okay, its degree is also 1. Why? y1 power 1 at most is present. That's all. No question of any higher exponents given to y1. Therefore, it is of first order and first degree. Well, my dear friends, you are supposed to observe the sentence given in the question very carefully. By following the essence only, we trace the standard family of the given curves and then produce the differential equation like this. Next one, we have seen straight lines, we have seen parabolas, we have seen some parabolas and some ellipses, some hyperbolas also. We have not touched the circles. Let us do the same. We shall now think of various circles. The first question, what is the differential equation of family of circles centered at origin? That's all. What is that? DE of family of circles centered at origin. That is the question. It's very simple. Centered at origin means, what is the general equation? Let the radius be r, hence the equation is x square plus y square is equal to r square. What is the parameter then? R. So, equation is x square plus y square is equal to r square. Its differential equation is 2x plus 2y y1 is equal to 0. That's all. So, x plus y y1 is equal to 0 is the differential equation because there is only one constant that is to be eliminated. We have done it. That is the differential equation. That's all. Isn't it? This is the very first form of the circle. Okay then. Next question. Centered on x-axis. The next question is differential equation of the family of circles centered on x-axis. What is that? X-axis and passing through origin. And passing through origin. And passing through origin. How can you get it? First of all, in order to have the differential equation, you are supposed to frame the original family, equation of the family first of all. Unless you know that equation, how can you get the differential equation? So, our first duty is to trace the equation of the family. Okay, what is that? Passing through origin and centered on x-axis. What is the general point on x-axis? Say A0. A0. And it passes through origin. Therefore, this distance is just nothing but A. So, by understanding the sentence given in the question, you can view the system and immediately you will be able to have the equation of the system. What is the system of circles here? X minus a whole square plus y minus 0 whole square is equal to a square. Hence it is x square plus y square minus 2ax is equal to 0. Is equal to 0. This is the equation of the system, not the differential equation. So, you find the differential equation. How can you get it? 2x plus 2y y1 minus 2a is equal to 0. Well done. So 2a is equal to 2x plus 2y1. Call this equation 1. Therefore 1 becomes x square plus y square minus, in the place of 2a what can you write? 2x plus 2y1 into x is equal to 0. As a result, what are you going to have? Y square, x square and minus 2x square. So minus x square minus 2xy1 is equal to 0. Is it right? Y square, okay, only once. X square minus 2x square is minus x square, and minus 2xy1 is equal to 0. Come on, my dear, what is the order and degree of this equation? First order and first degree again. So, in order to reach the answer, in order to arrive at the correct conclusion, you must be knowing the diagram and equation of the family, and then only you will get the differential equation required. Yes. Okay. In this problem, what happens if I change just one simple word? Differential equation of the family of circles centered on y-axis. Now I am asking you. That becomes another problem. The shape of the circle will be changed now. How can it change? Let us see. The third question we are dealing with. Differential equation of the family of circles centered on y-axis. What shape does it take? Let us observe. That will be the general shape of the circle. Centered on y-axis, let me take it as 0, a. Its radius is also a because it passes through the origin. It passes through the origin. It passes through the origin. Okay, what is the general equation of the system of such circles? X minus 0 whole square plus y minus a whole square is equal to a square. That is x square plus y square minus 2ay is equal to 0. Just like in the previous case, here also we have only one constant to be eliminated, no problem. It does mean that only once you may have to differentiate. We have done, what is that? X square plus y square minus 2ay is equal to 0 is the given system. Differentiate with respect to x on both sides. 2x plus 2y1 minus 2ay1 is equal to 0. From this, 2a is equal to 2x plus 2y1 by y1, isn't it? I think you might have you collected the idea. Why should we get the value of 2a? Justly to substitute in this equation, isn't it? Actually, in the answer of the differential equation, no arbitrary constants are supposed to be obtained. Well, in the place of 2a, we have 2x plus 2y1 by y1. So, 1 implies x square plus y square minus 2x plus 2y1 by y1 into y is equal to 0. That is the given equation. Of course, according to the necessity and according to the facility, you can simplify that. Come on, multiply it with y1. What happens? y1 into x square plus y square minus 2x into y. 2xy minus 2y square y1 is equal to 0. From this, we can get y1 as a common factor. That also can be done. From that last equation, get y1 as a common factor. What happens? X square plus y square minus 2y square. Come on. What happens to that? X square plus y square minus 2y square is nothing but x square minus y square. And minus 2xy as you like it. If you want to retain here itself, retain it. Or otherwise, throw it that side. What happens? It is 2xy. So y1 into x square minus y square is equal to 2xy. Look at that, my dear. Previously, in the previous problem, they are centered on x-axis. You observe that differential equation and this differential equation. There are a lot of differences there, you know. Yes. Depending on the nature of the equation of the given family, differential equation will also be changed like this. Yes. In this way, we get it. Moreover, what is the order and degree of this equation? This is of first order and first degree only. No question of y1 square here, no? No y1 square. First order and first degree. Yes. Next one. The next question. dE of the system of circles touching both the axes in the first quadrant that is the question. Differential equation of the family of circles touching both the axes in the first quadrant. Again, let us trace the family, equation of the family. That is the general shape of the system of circles. We are not given about the center and radius, but only one information has been given. What is that? It touches both the axes in the first quadrant. Okay, let this be the center. Perpendicular distance from the center is radius. Let this be A. This is also radius. So as it is also A. We are clear. Everything is clear. Center is A comma A. Center is A comma A. Well done, well done. What is the equation of the family? X minus A whole square plus Y minus A whole square is equal to S. X minus A whole square plus Y minus A whole square is equal to A square. What is the standard equation of the system? Is this. Simplify this. X square plus Y square minus 2AX minus 2AY plus A square is equal to A square. So 1A square will be cancelled, leaving you 1A. 1A square will be cancelled. That is the equation of the system. X square plus Y square minus 2AX minus 2AY plus A square is equal to 0. How many constants are here to be eliminated? Again, here is only one constant. How many times you are supposed to differentiate? Only once. Let us do the same. Let us do the same. What happens? Implies 2x plus 2y y1 minus 2a minus 2a y1 is equal to 0. So that 2x plus 2y y1 is equal to 2a into 1 plus y1. 1 plus y1. Send this to that side. What happens? 2a is therefore equal to 2x plus 2y y1 by 1 plus y1. And we are supposed to substitute this 2a here in this equation. This is the given equation. Well, how to get the differential equation? It is an easy matter. You are supposed to substitute this here. Let us do the same. And for that purpose, I would like to remove this figure. I think you would have understood. You could have traced by looking at the sentence given in the question. It is not impossible to trace it. Okay. Therefore 1 becomes, means we are ready to substitute this value here. What is this actually? X square plus y square. Let me make minus 2a as a common factor here. What it will be? Minus of x plus y into 2a. Minus of x plus y into 2a. 2a, isn't it? Minus of x plus y into 2a. What is 2a? 2x plus 2y y1 by 2x plus 2y y1 by 1 plus y1 plus 2x. What is a? From this you can have a. You can cancel 2 on all the sides. So that a is x plus y y1 by x plus y y1 by 1 plus y1 whole square is equal to 0. That is the equation. And to get it simplified, you have 1 plus y1 whole square into x square plus y square minus 2 into x plus y into x plus y y1 into 1 plus y1 plus x plus y y1 whole square is equal to 0. That is the equation. And it can be simplified according to the need of the question. Depending on the nature of the options given in the question, you can simplify that. You can simplify that. It's not impossible. You can do on the spot itself. You get first of all y1 squares. y1 square into x square plus y square. There also y1 square will also be there into 2x plus 2y. Here also it is there y square. Oh, you can simplify. It's not impossible. It can be done. This is the differential equation. Come on friend, you please tell me the order and degree of the differential equation. What is the order? y1 is only present, first order. And y1 square is available, no doubt. y1 square is available, therefore it is of first order and second degree. It is of first order and second degree. The next question is, what is the differential equation of the system of circles passing through origin? That's all. It's very simple, you see. And we recollect that the general equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. And if it is given that it passes through the origin, what happens? C becomes 0. Then what is the nature of the standard form then? X square plus y square plus 2gx plus 2fy is equal to 0, isn't it? Therefore, the given family is equation of the given family is, come on, x square plus y square plus 2gx plus 2fy is equal to 0. How many constants are here? 2 constants are there, g and f, they are to be eliminated, isn't it? So how many times at most you can differentiate? You can differentiate twice because there are 2 constants. Okay friend, you do it once. What happens? 2x plus 2y y1 plus 2g plus 2f y1 is equal to 0. 2. Okay, x plus y y1 plus g plus fy1 is equal to 0. Is equal to 0. Again differentiate it. 1 plus y y1. You are supposed to use the product rule of differentiation in this case. U derivative into v plus v derivative into u plus fy2 is equal to 0. Therefore, y1 square plus y2 plus fy2 is equal to 0. The thing you have to do is get f from this. substitute here. You will then get G. Use the value of F and G here. That is a risky process. We can have the answer in that way. In that way. As there is no other alternative. Well, of course, in such questions, usage of matrices and determinants is also helpful. How can you find that it is helpful? Okay, you try to solve it. You get F from here, substitute here. You can get G. Both G and F now substitute here. You will have the answer. That is the process. Okay, how can matrices be used in obtaining such equations? We shall solve some equations and then use that procedure here. Okay, yes. Y is equal to C1 into e power 2x plus C2 into e power 3x. You are supposed to eliminate C1 and C2. You are supposed to eliminate C1 and C2. How to eliminate? How many constants are supposed to be eliminated? 2 constants are supposed to be eliminated. What are they? C1 and C2. Okay. First step of differentiation, y1 is equal to C1 into 2 e power 2x plus C2 into 3 e power 3x. Therefore, y1 is equal to 2c1 into e power 2x plus 3c2 into e power 3x. Again differentiate it, y2 is equal to 4c1 into e power 2x plus 9c2 into e power 3x. Am I correct? Yes. Now call this 1, this 2, this 3. Now you eliminating C1 into e power 2x and C2 into e power 3x from 1, 2 and 3. At a stretch, in one single step, we can eliminate these two. How? Look here. What is LHS? Y, Y1, Y2. Y, Y1, Y2. What is the coefficient of C1 e power 2x here? 1. Coefficient of C1 e power 2x here? 2. Coefficient of C1 e power 2x here? 4. Coefficient of C2 e power 3x? 1. Coefficient of C2 e power 3x? 3. And the same here, 9 is equal to 0. This is the way we eliminate the constants. Okay, you use obtain determinant. 3 minus 2 is 1. Y2 minus Y1 into minus Y1 into 9 minus 4 is 5 minus 5Y1 plus Y into 18 minus 12 plus 6Y is equal to 0. You look at that how simple it is. So it is d square y by dx square minus 5 dy by dx plus 6y is equal to 0 is the differential equation of second order and first degree. Yes, first degree. Well done. This is the process of eliminating the required constants. Of course, it will be quite possible in problems of this kind. At times, it might be possible in other different problems also. Well, let us observe one more such thing. Y is equal to a into e power 5x plus b into e power 6x. A similar problem of the previous type. Okay, there is a small hint involved here. We shall explore that hint. Look here. What is y1? 5a e power 5x, 6b e power 6x. What is y2? 25a e power 5x, 36b e power 6x. Eliminate the required y, y1, y2, 1, 5, 25, 1, 6, 36 is equal to 0. Come on, y2 into 6 minus 5 is y2 minus y1 into 36 minus 25 is 11 minus 11 y1 plus y into 536 or 180. 180 minus 150 is 30 plus 30 y is equal to 0. What I mean to say is, well, my dear, you need not have all these steps. There has been a beautiful hint here. D minus 5 into D minus 6 of y is equal to 0 is the differential equation. What does the D stand for? Where D is the differential operator. It is an operator. What is D minus 5? D square minus 5 plus 11D plus 30 of y is equal to 0. That is, D square of y means d square y by dx square. 11 into d of y minus 11 dy by dx plus 30y is equal to 0. How simple it is to look at, to have the differential equation on this part without manipulating all these things, differentiating one time, second time, third time, like that. You need not do all these things. You can have the answer like that. Okay, how could you plan this? D minus 5 into D minus 6. You observe these numbers. You just forget these constants. Okay, right. Let us now try to generalize this. Let us try to generalize this. If y is equal to c1 into e power alpha x plus c2 into e power beta x, then d minus alpha into d minus beta of y is equal to 0 is the differential equation required. We are supposed to eliminate c1 and c2, but not alpha and beta. You can recollect that one. Alpha and beta might be present there. Actually, alpha and beta are known constants and c1 and c2 are arbitrary constants. The things that are to be eliminated is c1 and c2. Well, my dear, let us have a good practice of this. Y is equal to c1 into e power x plus c2 into e power 3x. What is the dE? Come on, you must be able to have the answer. You see, in order to simplify this, it can be done like this. D square minus of alpha plus beta into d plus alpha beta of y is equal to 0. This also you can write. Come on, tell me. What is the differential equation? Is d square minus alpha plus beta 4 into d plus alpha beta 3 of y is equal to 0. What does it mean? D square of y, y2. D of y, y1 plus 3y is equal to 0. Okay. Y is equal to a into e power 2x plus b into e power 7x. Come on, what is the differential equation? This is the formula. D square minus alpha plus beta 9d plus alpha beta 14 of y is equal to 0. What is the differential equation? D square y by dx square minus 9 into dy by dx plus 14y is equal to 0. Come on, friend, what is the order and degree of this equation? This is of second order because d square is present. First degree, d square whole power 1 is only present. That is why this is of second order and first degree. Well, my dear, you please keep this in your mind. This has a very beautiful reusability that you can take as a formula. As of course, the basic is d minus alpha and d minus beta of y is equal to 0. Well, so by looking at that, we have plenty of applications. If an equation with two arbitrary constants in this pattern is given, we can on the spot have the differential equation like this. One more. Let us look at one more such problem. Find the differential equation of the family of curves whose equation is c1 e power x plus c2 e power 2x plus c3 e power 3x, eliminating the constants c1, c2 and c3. How many constants are there? 3 constants are there. So how many are to be eliminated? 3 constants are to be eliminated. How many times you can differentiate? 3 times. Let us do that. y1 is equal to c1 into e power x plus 2c2 into e power 2x plus 3c3 into e power 3x. Again, y2 is equal to c1 into e power x plus 4c2 into e power 2x plus 9c3 into e power 3x. Again, y3 is equal to c1 into e power x plus 8c2 into e power 2x plus 27c3 into e power 3x. Wow! 4 equations are there, you know. By eliminating C1 and C2 and C3, what is the resultant equation? Y, Y1, Y2, Y3. 1, 1, 1, 1. 1, 2, 4, 8. 1, 3, 9, 27. And it is not an easy matter to have the different determinant of this 4 by 4 matrix. It's not impossible. It's not so easy, isn't it? Of course, by using some row operations or column operations, it can be reduced, you see. Well, my dear, to avoid that type of bulky as simplification also, there has been a hint. We can extend the previous hint as, what are the answers here? D minus 1 into D minus 2 into D minus 3 of y is equal to 0 is the answer. You just forget about C1, C2, C3. D minus 1 into D minus 2 into D minus 3 of y is equal to 0. That is D cube minus 1 plus 2 plus 3. 6D square plus 1 into 2 plus 2 into 3 plus 3 into 2. 2 plus 6 plus 3. 11D minus 6 of y is equal to 0. So, D cube y means y3 minus 6 y2 plus 11 y1 minus 6 y is equal to 0. No doubt this is of third order and first degree. Well, my dear friend, you simplify it with sufficient patience, you will be going to get the same answer. You will be going to get the same answer. Well, let us now try to create a general statement to have the differential equation of the family of curves which look like that. Yes. If y is equal to a into e power alpha x plus b into e power beta x plus c into e power gamma x, then the dE whose solution is the given equation is of 1 is, come on, d minus alpha into d minus beta into d minus gamma is of y is equal to 0. That is d cube minus alpha plus beta plus gamma into d square plus alpha beta plus beta gamma plus gamma alpha into d minus alpha beta gamma y is equal to 0. Alpha beta gamma of y is equal to 0. You may get another doubt. If y is equal to a power alpha x plus b into e power beta x plus c into e power gamma x plus d into e power delta x, if there are 4 such constants to be eliminated, then also we will be able to extend this. How? D minus alpha into D minus beta into D minus gamma into D minus delta of y is equal to 0. That gives you the answer. Yes, it is a beautiful procedure. Yes, it is a beautiful procedure. Instead of differentiating thrice and having a big determinant, expanding it, avoiding all that simplification, you just can use this formula or a result. Well, let us practice this. I think you could have followed this step. This is a beautiful hint. Yes. How to get it? How to get it practiced? We shall now look at. Look at this. Y is equal to a into e power 2x plus b into e power minus 3x plus c into e power 4x. You are supposed to eliminate a, b and c. What is the required answer? It is d cube minus alpha plus beta plus gamma into d square plus alpha beta plus beta gamma plus gamma alpha into d minus alpha beta gamma of y is equal to 0. That is the result, the technique which we could have developed. Okay, right. That is d cube minus 2 minus 3 plus 4. How much? 6 minus 3 is 3. 3d square plus alpha beta minus 6, beta gamma minus 12, gamma alpha 8 of d. Alpha beta gamma 2 into minus 3 minus 6 into 4 minus 24 minus 24 of y is equal to 0. D cube of y, y3. D square of y, y2. Minus 18 plus 8 is minus 10. Minus 10 y1 plus 24 y is equal to 0. It's a beautiful answer. Instead of differentiating thrice and a huge determinant for producing a huge 4x4 determinant and expanding it, it is a cumbersome process. This is very happy to have the answer. Okay then, next one. Suppose y is equal to c1 into e power mx plus c2 into e power minus mx is there. We are supposed to use the previous hint, of course. Here alpha plus beta is 0. I think you could have observed it. Alpha plus beta is 0. So the direct answer is d square, no question of getting any d, plus alpha beta, that is minus m square of y is equal to 0. Therefore, d square of y is y2 is equal to m square y is equal to m square y. Yes. So, as and when you look at such things, please don't forget to use this. y2 is directly m square y. Next one. Another, find the differential equation of the family of curve y is equal to ax plus b into e power 2x. Eliminate a and b. How many constants are there? 2 constants are there. How many times you can differentiate? 2 times. 2 or 3 steps will be obtained. Substitution, evaluation. Oh, there is a process of minimum 4 to 5 steps. You can avoid them also for this model. For this model, how can you avoid it? This is just nothing but d minus 2 whole square of y is equal to 0. That is d square minus 4d plus 4 of y is equal to 0. That is d square of y is y2, 4d of y is 4y1 plus 4y is equal to 0. You can. Shall we check it? It's not impossible. We shall do that. We shall do that. Look here. y1 is equal to a into e power 2x plus 2 e power 2x into ax plus b, isn't it? A into e power x plus 2y, isn't it? So y1 minus 2y is equal to a into e power x, correct? Again differentiate. y2 minus 2y1 is equal to a into e power x, correct? Subtract this from this. y2 minus y1 minus 2y1 minus 2y is equal to 0, isn't it? Minus 2 minus y1 minus 2y1 is equal to 0. The same thing you could have had in the previous case also, isn't it? y1 minus 2y is equal to a into e power x. Again differentiate. y2 minus 2y1. y2 minus y1 minus 2y1 plus 2y is equal to 0.